Hey Gary, you said
Unless he's
quantum
drunk.
mechanics is bullshit, but actually quantum mechanics has a
No,
greater
no, no,
precision
no,
a
no,
greater
no, no, no.
precision
Hey,
than
hey,
the
I'm not
general
gonna. Hey,
relative.
hey! Stop. Prove that I said quantum mechanics is bullshit.
Well,
Show me,
I think
show me where I said quantum mechanics is bullshit.
I think
Okay,
you're
quantum mechanics is math. Okay, what is bullshit is quantum theory. That's bullshit.
the mechanics are built into the theory.
No, I'm sorry. No, you can't play that game. Okay? No, the theory is multiverse, the theory string theory. The theories are numerous convoluted sacks of shit. All right? The mechanics, quantum mechanics, the math is just math. It's just probability math. It doesn't say anything extraordinary. It doesn't talk about randomness. It doesn't say the probability is anything real. It doesn't say that it's being created by a generator. It doesn't say anything. It just says we can't know if we don't have enough information to say where this photon is at this particular moment in this explicit second of time. And that's all it says. It doesn't say anything. It just says we're going to do the math even though we don't know exactly where it is. We know a probability, and it just takes the probability. I call it error math because it's just basically taking a huge error and just moves it through the math without letting the error destroy the math. And that's all it does. And it does it by creating this complex mechanism of vectors. And what's the other thing it uses to protect the fact that it doesn't have sufficient. It's like decimal places, right? And when you do math, you have to have the proper number of decimal places in the numbers you're doing. And so there's no point in doing math when you have one variable with only one decimal place. Then all the other decimal places, you might as well just throw them out in the woods because it doesn't
Significant
matter anymore.
digits.
Yeah, because you already have significant digits. So you already broke your significant digit rule. And all fucking quantum mechanics allows you to do is to do the math without the significant.
Gary, that raises an interesting issue to give me a 4. You couldn't give me a 4, so math is kind of subjective, but how do you think it,
No, I
unravels
couldn't
in with
give you a
the
four. A four is a category. Okay, that's all four is. It's a category. It's not complicated. Two is a category, and things that get put in that category have explicit and certain and definite and absolute characteristics. So it's not something I can't give you. It has an explicit definition. It's not an inexplicit definition. It's not a vague definition. It's an explicit, naturally occurring, factual existing thing. Two-ness exists, three-ness exists, four-ness exists. These are not fake things, they are real things.
Yeah, no, you would just agree with what I said. You can give me 4 of something, but there is no 4.
Well, I'm just saying there is four as a concept. A concept is a category, has a definition, and math has very explicit definitions. There's no problem with math. Math is a discovered, it's a revealed truth. Math is
Okay,
not
so
a made
yeah,
up
all right,
truth.
so 4, yeah, okay, so 4 apples and 4, glutons are not the same. It's just a number.
They're the same. Who said they're the same? They're the same in the sense that there's four. They're the same in that you call them white, or you call them black, or you call them green. That's what they are.
Yeah, it's a descriptive definition. It's not something, though.
It's idiotic not to say it's not something. It's a fucking description of a real event. It's like rain, or it's like magnetism, or it's like electricity. It's a real event. We're describing its realness. Two-ness is a reality. Three-ness is a reality. Four-ness is a reality. It's not fake. It's not made up. It's not inconsequential. It's fucking real. It's
Gary,
perfectly accurate. It has no flaws.
the only physics theory that provides a somewhat accurate description of how things work at the quantum level is quantum theory. I mean, Newtonian mechanics doesn't work at
No,
all.
I'm sorry. There's no such thing as quantum theory, so it's just crap. All right. What quantum theory are you talking about?
I'm talking about quantum mechanics. You know, the
Well,
equations
that's
of quantum
not a
mechanics.
theory. Quantum mechanics is math, okay? Again, you're just not getting it. Quantum mechanics is mathematics. It doesn't say anything about what causes the effect. All it does is create a mathematical mechanism with which you can understand or see how the effect will play out. But it does not explain cause. Quantum mechanics has nothing to do with causation. Again, it's all just probability. You can see it in the numbers. I mean, you can use Feynman diagrams and and understand it explicitly. You can understand that this is something that these probabilities happen for a structural reason. You can almost see it in a Feynman. I mean, I don't know why Feynman didn't even just say it. Like, look, I got the diagram here. Basically, we understand that this is a physical mechanism. I mean, Feynman even said that in one video. I was happy about that, where he actually said the idea that he thinks the whole thing breaks down to a checkerboard. That it all breaks down to a very simple mechanical structure, and that we can't see it because it's too small and there's too much of it.
Yeah, well, I mean, I've heard like everything could be pixelated, almost like a Sims type of environment, and that doesn't seem too far off.
Well, I'm just saying that the mechanics behind quantum mechanics are mechanics. They're not fudge. They're not magical. It's a mechanical process. These photons have a condition. And their condition, as I'm pointing out with the two-slit experiment, their condition is unique. And that's why they behave differently than each other. One will react different than the other one because they have a different source. They're a different age. They are going to electromagnetically react with material splits in different ways because of their different origin. And that's the probability. That's what is revealed. Like I said, I mean, I'm going to work some more on this glass thing because it's very interesting, these layers of glass and how photons travel through glass. But it's really interesting on how, the effect of how there's, how you get double the reflectivity, and, based on how thick the glass is, it changes how reflective the glass is, and really interesting effects. But all those effects are being caused by a mechanical process, not a magical process.
So do you think that all these atoms or photons are of different trajectories and different ages will eventually cause them to kind of split apart in the end? I mean, the
Well,
whole universe.
I do think there might be actually, as funny as this sounds, but I mean, you might be able to mix like 3 ingredients, like an egg, a frog, and an eye of a newt, and actually blow up the universe. I mean, I think it's actually possible that the entire structure of the universe could be destroyed just by causing a chain reaction in regular matter. So that it is theoretically possible to disintegrate the bonds that hold atoms together by introducing some sort of hypermatter, that would fuck up all the nucleuses of all the atoms or something. So yeah, I
So
think
it's like a really so it's like a really complex knot, and you're just finding the part that you pull apart, and the whole thing comes apart.
yeah, it's all made out of thread or whatever you want to break it down to. But yeah, it's all made out of photons. All the matter is photons. It's just photons trapped. So if you think of it that way, that the entire universe is just photons. Photons moving at the speed of light. And the ones that get trapped in orbits around each other turn into electrons and neutrons and protons and all that shit. But they're made out of photons. And so they're just still photons spinning around each other instead of going in a direction. So instead of going in a direction, they're caught spinning around each other like magnets caught in a dance. And they're just chasing each other's tails in this spin. And so all matter is really just photons waiting to be liberated, saying, let me loose, let me free, so it's like just, so it's all like a gravity that's just holding everything together. And once so there's theoretically, you could just pull one string and everything starts to unravel.
I don't know about that, Gary. Photons are supposed to be massless, and electrons, protons, and neutrons all have masses.
But that's not true. So, physicists don't agree on that massless thing. See, it's only massless because that was the standard applied. They said this is where we'll have the 0 point. But the 0 is an arbitrary. So if you just move the standard up one notch, you'll create mass in a photon. So, I mean, obviously Feynman thought photons had mass because they obviously impart energy. That's how you can make a solar sail, is because photons have a mass, because they obviously impose energy onto the surface they hit. And something without mass couldn't possibly convey energy. So, I think it's silly to say they don't have any mass. They have obviously the smallest mass because they're made out of the smallest thing, the quanta. I mean, one photon could be 1,000 or 1,000,000 or 1,000,000,000 quanta. Who knows? But I'm just saying the photon itself is the smallest collection that we can detect of energy. There might be smaller bits of energy floating around the universe, but obviously we have no way to detect smaller bits of energy because they don't have any effect on atoms, and atoms are the only things we can, it has to affect on an electron or bigger for us to be able to really detect it. So it would become irrelevant what the substrate is. Okay, maybe all that dark matter is out there in the form of disassociated quanta, but I'm still going to theorize that no, the only real quanta is the stuff moving at the speed of light, and the smallest thing it's in is whatever the cosmic ray, and everything else is some bigger version, some longer wavelength of the same thing. But they get bigger as you get further further down the scale of the electromagnetic spectrum. But the electromagnetic spectrum is all of energy, and that's really it. That's the game. And so everything's made out of those photons in different forms. I mean, photons that are in the form of light are the ones that are the most numerous, but there's a lot of photons in the form of radio waves and all kinds of other particles. But yeah, thank you for the conversation. I know it's a subject most people hate it, so I don't want to stay on it forever, but I really find it interesting, physics. Lots of ground to work on.
I know it's fascinating. There's a kind of beauty to it.
Well, I just like the puzzle there. It's a puzzle that just, they haven't, it's there to be solved. There's a puzzle here, and people are just letting it go, and I'm like, no, this is like a Rubik's Cube. Let's figure out how to do it. I mean, it's there to be solved. Nobody's done it. No one's drawn a really good picture of what the fuck the universe is doing.
So Gary, you were saying that you thought the photons have like maybe a really small amount of mass, but have you ever considered that it might just be pure energy, and like when that energy hits something, then maybe it like converts to mass or something?
All it can hit is an electron or a nucleus of an atom. That's all it can hit. So you have to explain this energy just floats around, it hits an electron and imparts energy onto the electron. And I'm just saying, I don't think that makes any sense, because then the electron releases another little packet of energy. I mean, I think it is a thing, so I just don't think there's any point in saying, and I just don't see any reason to say it doesn't have mass, because it acts as if it has mass. It has all the properties of something that has mass. It's deflected by, Einstein proved it. Okay, I mean, light is deflected by gravity. How could something with no mass have its trajectory altered by gravity?
Yeah, I mean that makes total sense, and I mean when you consider like like the equation for kinetic energy, 1/2 mv squared, something can't have energy unless it has a mass in that kind of situation.
Yeah, well, like I said, I just think that the reason why it's perceived as a neutral mass is just because it's the starting mass, So, it just got called 0 when it probably should be called +1 or whatever. It's just the scale. It's a little bit broken. They just made the ruler a little bit wrong because they didn't realize that their scales can't measure the smallest thing. You can't make a scale to measure the smallest thing on, right? What are you going to make the scale that you measure the smallest thing out of, right? So how do you measure the smallest thing?
Right. Yeah.
Right.
At, at, at the same time, though, photons, they don't accelerate to the speed of light. They just immediately are at the speed of light. So it seems unlikely that you could
I know, but
accelerate some
the acceleration
mass.
is the key word. I know, no, but remember this. I'm telling you that I don't think they ever accelerate, right? See,
Yeah,
what I'm
yeah, I
saying is
get
the
that.
photon is never created, it's just released. So photons aren't generated by anything ever. They're just released from a trapped orbit. So there is no, it's like saying if the moon got free of the Earth's orbit, you wouldn't say the moon accelerated. You'd just say the moon was liberated. So there is no reason why it would accelerate because all you're doing is liberating something that's been trapped. So that's why matter can't be created or destroyed, is because the matter is energy. The matter isn't made out of something else, it's made out of photons. And the photons have always been going the speed of light and will always go the speed of light, and all you can do is release them and not release. You can capture them and release them, and that's all you can do. And that's all the universe is doing, is really capturing and releasing photons. It's not doing anything else. So my vision of the universe would be like some sort of three-dimensional grid, where you can bend some of the grid work, with gravity and such, and it's just photons traveling through that grid work until they get caught in these loops, and these loops become, interlocking, like interlocking rings that a magician uses. You can, they have an opening at the end, and they can hook onto each other, so the loops get caught, and that starts to build your matter. And I kind of, what I like is I have this vision of an electron as two photons rotating. So that creates your spin on your electron. So if you have two photons that might be a string of quanta, like little beads, and they get tied into each other, then they start moving in a circular manner around each other. Then they start using up their speed of light because they're using some of their speed to go in the circular manner. So that's why electrons can move at variable speeds. It's because the faster they spin, the slower they move laterally. So that's why electrons can move very, very fast or pretty damn slow, is because it all depends on how fast they're spinning.
This probably seems like a really silly question, but what is actually like an electron? Like, how would you describe an electron? Because I've been trying to figure that out, and I've been looking it up, but I can't really
Well, I think
understand what an electron actually is, or a proton.
well, electrons have a wonderful fascination for photons. I mean, photons and electrons are, they're doing most of the interacting in the universe. So electrons are always releasing photons and capturing photons, and this is what they're doing all the time. So I think the idea of thinking about an electron is just being, okay, magnets, they got all stuck together, and so they're in a they're in like a DNA molecule, so it's a double helix, and they spin around each other. And when they're trapped inside an atom, what I'm suggesting is that they're trapped inside a loop, so they're chasing their own tail. So they're a bunch of magnets all stuck together, and then at the end point they don't quite stick because it's north on north or something. So there's a little gap at the end, but they're still chasing the end, and so they're just chasing their own magnetism in a sense, and they're just spinning on that at the speed of light. And well, not at the speed of light because they're spinning at the same time. So that's what makes it complicated. But yeah, so just think of it like you could say 1,000,000 photons, or you could say 1,000,000,000 photons. So you could say an electron is like 1,000,000 photons just caught in a loop around an atom. And when you liberate an electron, then it's just this string of, size and of photons spinning this way and moving that way.
That's probably one of the problems I had with learning science in school. They never really broke anything down for me. Like, I mean, what actually is an electron? Like, what is the actual theory behind it? What is the physics of it in
Yeah, well, the
chemistry
models
class and all that? Now it's extremely frustrating.
the models suck. I mean, even the current standard model is so convoluted, and they're looking for this bosons and hosons and sozons, and I mean, they're just going to go on forever with these synthetic particles they keep making up to glue everything together. And, you know, I think the whole thing has gotten quite, you know, wonkery. It's just gotten quite wonky. And it doesn't tell you anything about what's really going on. So yeah, the models, I mean, when I was a kid, the models would really suck because they were just like, oh, it's like a solar system. So it was really lame because there's no way you could imagine a solar system with things spinning that fast and, you know, so far away from the nucleus, and, you know, none of that made any sense. But I think my idea of the connecting rings for the orbits makes a lot of sense, because that explains why these orbits seem so eccentric and so distant from the nucleus, is because they're rings connected.
I mean, to me, it's funny that you mentioned how the whole solar system analogy was sort of broken for you, but I mean, even now, like, that's how I'm sort of imagining it. Sort of just this smaller scale of a solar system that's just going a lot faster.
So the problem we have is that we have these invisible things that are in, you know, the forces that are all invisible, and so you know, I still haven't gotten it completely figured out. But, you know, this whole idea of velocities and you know, the center of gravity of matter moving through space, you know, it sort of makes you sort of understand that it's, you know, when you move, when something's moving, it's not being accelerated anymore. Let's say it's just already accelerated and it's moving. So you have a spaceship in space, the rockets fire, it's moving. What keeps it moving? Right? I mean, the only thing that's keeping it moving is its internal forces, right? So something inside of it must be saying, go that way, right? I mean, there's nothing external telling it where to go. There's nothing pushing it anymore. So obviously it's something inside of it that compels it to keep going. And so once you understand it in that way, you start losing this idea of a force, and you start thinking about, again, like, oh yeah, these are mechanical things, not forces. Forces is what we have called the things that are invisible. But the things that are invisible probably aren't invisible. They're real effects. And once you change something, once you change its interior structure, well, if I told you that more of the light inside of the matter of that rocket was moving in that direction now, you know, in its orbits, so all of its matter was aligned up in such a way that when the electrons and the photons spun inside the atoms, more of them spun in that direction than in that direction. So they ended up going that way because more of the light inside of the matter is going that way. So, you know, that's, you know, when you start thinking about it in those terms and you start understanding, oh yeah, it's not a force, it's something that changes the structure in me. So gravity, it isn't creating a force pushing me down. What's happening is gravity is changing the structure of the space with my atoms are in. And now my atoms are pushing me down. My atoms are saying, I want to go to the center of the Earth. You know, in terms of the speed of light overall is heading down. And so the force is inside me, not some external thing pushing me down. It's an internal change in my structure that's compelling me to go down.
I mean, I'm almost thinking about how they taught me space and how that was all wrong too. Like, they were teaching me if you went into one distance at a certain speed, you'd continue at that distance forever, but I mean, that's really not true. When you revolve around, when you get nearer to the Earth, or your periapsis or whatever, you start accelerating even faster, even though nothing is really forcing you to move faster, in a sense.
Well, I'm just saying what's forcing you is the change inside your molecular structure. So I'm just saying anything that changes the orientation of your atoms, so even something electromechanical, right? Like a magnet, what is it doing? Right? There isn't two things pushing the magnets together. There's something happening to the structure of the magnets that's forcing their electrons to point in those directions. So it's all very electromechanical. You can see the electricity and its effects in terms of an electromagnet. You can see what it does. And I'm just saying those effects are just like gravity in the sense that it creates this force, but it's not a force and as if something's pulling it. It's a force inside in the fact that it's changing the molecular structure of the thing. So when you magnetize a piece of steel, what you're doing is changing the electrons, the orientation of the atoms inside of the steel. You're aligning the atoms in a particular way so the steel becomes a magnet, and it has a plus and a minus pole because you have realigned the atoms inside of the steel. And so I'm saying is that all these forces aren't really forces, they're changes in the internal structure of the matter itself, and the matter itself is making it do the thing. So the matter's doing the thing because it's been reoriented, and by reoriented it, you change its net, the net equation of where its light wants to go. What I'm saying is atoms have a native directionality, you know, based on how they orbit. And so if they're allowed to orbit freely, they orbit eccentrically. And so that's the wobble in the atom, is the fact that it's changing its poles all the time. And so when it's oriented in a certain way with other atoms, all the poles will line up, and you'll end up with this net effect of, you know, more force at one end than you have at the other end. Or more force in a direction. So I'm just saying, once you establish that, you know, once, like say if I made the moon, when the moon was passing the United States, I pushed the moon 1 foot forward, you know, in its orbit. So every time it went past the United States, it got pushed one foot forward. So it's going in that direction 1 extra foot. You know what I'm saying? So there would be an overall balance, and it would change the center of gravity for the entire Earth-Moon structure would be changed because of that 1 foot difference. Because I skipped 1 foot, I have now changed the center of gravity of the Earth and the Moon combined. And so that's what I'm basically talking about, is that what happens when you realign these atoms is that you change their center of gravity, and it's their center of gravity that dictates whether they're going to move or not.
Alright, yeah, I'll definitely think about that more. Some of the stuff at the end was just way above me, but yeah, I'm definitely going to try to wrap my head around it.
Understand, like, you know, what makes it really visible is when you think about, you know, like I said, the stuff moving in space, and the fact that you can tumble it all you want. You know what I mean? Like I can make it spin or tumble, and I won't change its direction. So if I don't change its center of gravity, all I can, like say if I have a little rocket on the tip of the capsule's moving this way, and I have a little rocket here, and I shoot the rocket off, I'll just make it spin this way. It'll still go exactly the same speed in this direction. It won't go in this direction at all. It'll just spin on its own center of gravity. Now if I hit the rocket right on the center of gravity and then did the same thing, then I would move it. And so now it would be going the same speed in this direction, and it would also have a speed going in the lateral direction. All right, so it would have this diagonal direction be created because of the two different vectors you've created of acceleration. But you can only do it when you move the center of gravity. So it's really important. The center of gravity thing is the whole game. That's the thing to understand, is that everything has a center of gravity, and if you move the center of gravity, you'll force the thing to move. And so what happens inside of matter is the center of gravity is subtly changed by pushing the moon that 1 foot, that idea. So all I'm saying is all I have to do is change an electron, have it move 1 little bit extra on one orbit and 1 little bit less on the back orbit. You know what I mean? Just change the orbit and I've changed the entire center of gravity of the entire molecular structure.
Hey Gary, have you seen the movie Gravity? It was just made this year.
No, but I'll write that one down. Yeah, I did hear that somewhere, so I'll write that down.
Yeah, what you were just describing with like releasing a rocket from like not at the center of gravity. They do things like that in that movie. You'll probably enjoy it.
Okay. Yeah,
Well, I mean, it is like a Universal theme park kind of movie, but I mean, it is pretty accurate in terms of how space works.
Yeah, I mean they don't make any sound out there and stuff, so it's got that right at least.
Yeah, yeah. I always the Star Trek, you know.
Do you guys
Everything
know
makes
what the do you guys know what the speed is that space junk, everything that's floating up there? What do you guys know what the speed is?
27.684 thousand miles a second. 27,000 miles a second. Yeah, that's it.
Yeah, I
27,000
got no idea.
miles a second.
Well, you think all that space junk would be dangerous, but I guess because it's all traveling at the same speed, it's like I think in the movie one of the satellites gets blown
It
up,
is
and
dangerous.
then
It
it's
is
all moving faster, so it's accelerated space junk.
dangerous. It is dangerous. It is dangerous. That's why they stopped. Look, it's one of the reasons why they stopped doing the space shows, because they knew they couldn't go into any high orbits, because they knew they were going to get bashed by a fucking wrench.
The Japanese are developing a huge. That's their plan.
Yeah, well, it's going to have to be made out of something. Catch awful small particles too, but some of that shit the size of a BB, you know, moving at whatever 5,000 miles a second, and whatever the thing is, it's fast. Some of it's moving awful fast.
Have you heard of Mars One?
No, I've heard of that. Whatever it is, Neptune or whatever. What's that? Pluto 1 or whatever that Pluto probe is. That one's going to be such a fail. I predict the Pluto probe will fail. No fucking chance they're going to. They're going to fly by Pluto at really like 27,000 miles a minute or something. They're going to fly by. No way.
I wonder. Mars One is this like private organization. They're gonna send some people to Mars on a one-way trip, and they're gonna live up there.
Yeah, whatever. They're not going to do any of that shit. They'll send corpses to Mars. Wait, it take a year and a half to get to Mars. You don't think the fucking astronauts are going to beat the shit out of each other before they get there?
Apparently, some
ain't gonna be
guy
like
that
space.
has like a guy with 4 kids and his wife is just gonna sign up and leave.
Matter.
His kid.
As a
Well,
dick
it
to his
doesn't matter.
kids.
It doesn't matter. It ain't gonna happen, okay? Because it ain't gonna be like you're gonna send the space station to fucking Mars. No, they're gonna be in a tiny little capsule, okay? I mean, they're gonna be like constantly 2 feet from each other. There's no fucking way to spend a year in those tight of quarters. They're gonna find it too obnoxious.
They basically they want like the glory of it to just be like the first people on Mars.
So it doesn't matter. It ain't gonna happen. It's just like fucking Amazon's goddamn drone delivery. It's just bullshit. It's just propaganda lies. The guy's probably just selling tickets to whatever, some jerk-off park.
There's a moon landing truther in the comments, and he really believes it, I think.
Well, whatever. Who cares? You're a retard.
My biggest argument against that, I mean, it's so stupid, but we were in a space race with the Soviet Union, and they never disputed any of it. So if we landed on the moon, they would have called us on that bullshit. I mean, we went back 9 more times. The Soviets didn't say a word.
Well, it doesn't matter. It's stupid theory. I mean, when you look at their evidence, you're saying, what, are you fucking retarded? I mean, one of the things was like the image in a reflection in the window, and it was like the sun wasn't supposed to be out, and you could see that it's, you know, whatever. I can't remember exactly what it was, but it was like so fucking off, and you're like, well, look at the reflection in the window, you stupid fuck. You know, I mean, it's just, you know, you're like, how? It's like it was like 9/11 truth or bullshit. It was just like, oh, come on. There's not fucking bombs on the bottom of the plane, you dumb asshole. It's a fucking shadow.
No. The plane was it was a hologram, Gary.
Yeah, well, whatever. You just, you know, they get more and more desperate, and it's just so stupid. I still can't believe that people would even fall for that. Oh, there's a giant match. You know, does it need to ignite the fire? Oh yeah, you just plowed a plane full of the most volatile fuel on Earth into a building, and you need a match to light it? I don't think so.
And also on the moon, I mean, isn't there like a mirror that they placed on the moon where like you can shoot a laser at it and it'll come back and you can measure the distance?
Yes. Look, with a good telescope, you can almost see the shit on the moon. You can see the shit.